Imagine you're in middle school. You're at your buddy's house for a sleepover, you have pizza, soda, and an entire night of video games ahead of you. You're hunting aliens, and your heads up display gives you a map, a mission directive, and your character's health stats. Your virtual assistant offers you tactical tips to help you secure the base, and you finally beat that frustratingly difficult level that led to 3 broken controllers. Those carefree gaming nights may be in the past, but the concept of military men and women equipped with headsets displaying mission-critical intel, that's happening now. Vuzix is a company specializing in AI-powered smart glasses, waveguides, and augmented reality. It just secured a contract to provide customized waveguides for one of America's leading defense contractors. Those waveguides will be designed to operate in new, lightweight heads-up displays for military personnel. Rob Schultz is Vice President of Optics for Vuzix. He joins us today to talk about the technology making video game fiction into real tactical equipment. That conversation is next.
Today's episode is brought to you by Hamamatsu Corporation, a leading manufacturer of devices for the generation and measurement of infrared, visible, UV light, and X-rays. Hamamatsu is dedicated to the advancement of photonics through extensive research and offers specialized systems for select applications. Visit hamamatsu.com to learn more. Today's episode is also brought to you by American Elements, the world's leading manufacturer of engineered and advanced materials, with a catalog of over 35,000 products available in both industrial bulk and laboratory quantities. To learn more, visit AmericanElements.com. American Elements. Now invent.
From Photonics Media, this is All Things Photonics, a podcast where we explore industry-shaping advancements in lasers, optics, imaging, metrology, and sensing. Each episode, we'll speak with some of the brightest minds in industry and research about the trends shaping the landscape of photonics.
Now, I wanted to start Vuzix getting more involved with defense. Specifically, we saw press release providing waveguides for augmented reality and heads-up displays for military personnel. Can you talk to me about Vuzix's role in this technology and how these waveguides help shrink this tech for things like AR headsets?
Absolutely. Vuzix historically, has made components and systems for all different kinds of AR glasses, that kind of thing. In the last year or two, we've really been focusing on our OEM business, which is providing kind of not necessarily full system solutions, although we can do that as well, but customized components and that kind of thing to fit into other systems. So we're working with a number of tier 1 partners and providing components into systems that they're looking for. And what they're looking for typically are wave-guided systems to work within the augmented reality systems that they're building. So a lot of what we're doing is focusing on the mass production, particularly with the current administration and the way some of the politics are moving towards U.S.-based manufacturing, that kind of thing. We've always done all of our design and manufacturing of our waveguide systems here in the U.S. So we are a natural partner to a lot of the military in terms of being able to provide things to them that aren't going to, set off any alarm bells anywhere or anything like that. The products themselves that we're building, if you think about the products that have been out in the industry, you think about like IBAS was one of the big ones that was in the military, the Microsoft HoloLens kind of a system. It was a big helmet-based system with lots of system integrations, that kind of thing. One of the things that's been shifting that we've been seeing is more just displays or more kind of simplified systems or more kind of mobile systems, more where the soldiers or people on the ground could be a little more agile in what they're doing. And they don't need all those sensors, all the information all the time. So we're seeing a lot more kind of reasonable systems come down the pike instead of things that are kind of reaching for the moon, the sun, and the stars, trying to do too much and not achieving any of them well or enough of them well. So it becomes this big, heavy thing that too much battery, too much complexity, too much information, and just not what the end user needs. So as things have started getting a little more reasonable, as we've been kind of moving at the component level of it, there's been a natural, kind of symbiotic relationship with some of the customers in what we're building. Well, that said, we've got our new production facility here. We're set up to make, 1.5 million waveguides a year at the current capacity with room to expand beyond that. So we're looking at trying to bring low cost components into these systems and to be able to really kind of supply it out. Within military communities, they do everything that everybody else does. So they're doing, all of the logistics, all the different kind of things that happen. I mean, you've got, firefighters looking for, information over displays to look through smoke or that kind of thing. You've got the same thing in the military. So you got the ERs, you know, uh, you know, departments. You've got the military. You've got all these people using the same type of technologies as they're trying to do, and the logistics, moving things, barcode, know where things are. To be able to scan barcodes as they move. All that stuff is kind of so. Anyway, from the application side, uh, that's what that is. The basic technology what we're building underneath all this is the waveguides. And the waveguides themselves are um, a Plano piece of glass. What it largely does is it takes a projected image and moves the image over from the edge of the glasses over in front of the eye. And it uses total internal reflection to send the light through a piece of glass into the user's vision. The trick to this is if you think about the projector and you think about a small projector up on the wall, it's got a really small exit aperture on it that's projecting out into a big area on the wall that's scattering out into the room. So the angle at which that spreads out is the field of view, and it's effectively the size of the image that you're going to see in the glasses. But the problem with that is if you turn that projector around and looked in the other side, you'd be looking down the barrel of a very small aperture and a very big image. So it's like looking through a keyhole into something else. I think about it like a window onto a billboard behind it. The billboard's the field of view. The little keyhole is the aperture. In this case, we're trying to open that up and expand it, and that's really what the waveguide does. Is through TIR, it lets light out a little bit at a time as the light bounces down the waveguide, comes out towards the eye, and in that case, you've got exapupil expansion is what you have, and that's one of the original terms for the waveguides were exapupil expanders. Um, the so the waveguides, in order to do that, have to be super super flat, super super parallel, and have to put the image back together again after it's kind of bounced through the waveguides of TIR and kind of come to the eye. So using it for imaging applications, so very challenging. The flatness and parallelism of these things, they need to have local parallelisms to, in the order of a couple of arc seconds, which is, kind of, I've always thought about kind of like trying to align to take a telescope, align the rings of Saturn, and then put it down and try to align the top and bottom surface of a piece of glass to that level of accuracy is the kind of thing we're looking at. The very edge of what's possible is what we're building these things to.
And these waveguides, have helped shrink this technology because naturally, especially you talk about defense, you don't want that big bulky helmet. You want something more compact. That's not going to be a distraction to someone who's carrying out a critical mission. So, how do these waveguides really help shrink this technology and make something more compact, comfortable, practical?
Yeah, so the waveguide itself, so I mentioned the small exit pupil in the end and being able to expand it out. So what you're trying to do is to take something that's got a very small exit aperture and expand it out so it's a nice, big, friendly, viewable window in front of the eye. So it's useful to everybody. So it's not customized to the user that they don't have to go looking for the information looking for that it presents itself. But now that piece of glass can be really, really thin. So we can do that glass. Now, we need to look at impact resistance and how it's protected and how it's mounted in the helmet, and all that kind of thing. The materials it's made out of, chemical strength and that kind of stuff are all options. But it is, we're building waveguides that are down to 0.3 millimeters thick right now. So you've got a 0.3 millimeter thick piece of glass in front of the eye. It's generally plano, but aside from that, there's not really any limitations to what it can be. We can change the shape, change the way it's configured. We've got different types of grading patterns we use to move the light from the pupil over in front of the eye. So, all shapes and orientations are, possible at that point in time.
I'm curious with the AR headsets. Can you give me an example of what the kind of things that someone in defense may actually see on this headset when it comes live?
Yeah, so it really depends so much on the application. I mean, at the end of the day, you know, to a first order, you've got something analogous to a phone in terms of what those controls are going to look like. But you could have, a map, you could have overlaid informational reality, you could have, you know, thermal or low light, sensors kind of put back over the display you're looking at, and information and markers kind of put on things in real time. You can have uh, simple menus or simple, tactical information, time, date, weather, location, basic arrows saying go this way, you
Yeah.
know, and it can go almost anything from full Iron Man down to, information you might have on your Apple Watch or something. So it's that full spectrum of, how much telemetry data can you handle at one time, down to, hey, what time is it?
Yeah. That's very interesting. I like the it feels like, and in my head I'm thinking back to like me in middle school, like Call of Duty. There's the map, there's the the blips of like here's the people, and who knows to say that's not so far off from what could potentially happen. If you have a satellite spotting people with infrared, you have that fed there. Something kind of similar could happen.
Well, the tail wags the dog. So, I mean, the, uh, you know, the entertainment industry, the gaming industry, all that kind of thing is certainly driving some of what the expectations are. At the end of the day, ground soldiers gets handed this piece of high tech. That's what they're expecting it to do. So to some extent, every time something doesn't meet their expectations, people are going back to the drawing board saying, hey, why doesn't it do that? And, it's been a struggle through the years to some extent, because the entertainment industry has created a really, really high expectation of what this technology does. But then it's also challenged us to come back and meet those expectations. So I think to some extent that challenge is something we've been, working hard to accept.
And talk to me more about the evolution of AR and VR technology in military applications. I mean, this is not, this felt like sci-fi, like even like 10 years ago, to see like the digital displays pop up now. But how did we get here, and where are we going?
Yeah, well, it's funny. One of the things that I would say is that the military has been looking for versions of this for a long time. They've had, SIBR requests and that kind of stuff, small business innovation requests, and that kind of thing have been, we participated in a number of those a number of years ago, I recall. But um, the general progression of it has been that they asked and they've been looking for the Earth, the Moon, and the stars. So there hasn't been a lot of things that kind of fill that middle ground. And what I would say is really changing the most is that they are looking for more of those middle ground solutions. I think that the small phone computers and that kind of thing, so many think like tablets and that kind of stuff have really changed the way that the military interacts with information, but it also changes the way that they interact with suppliers and customers and that kind of stuff as well. So that, they're more open to using an off the shelf component. They're more open to using, uh, consumer developed technologies kind of a thing. And then what we're offering on top of that is, let's get this away from something that light up and shine on your face and something you hold in your hand and something you need to work with, and replace it with something that can be on the head mounted, that can kind of disappear into the technology that's already there. They're already wearing helmets. They're already wearing backpack batteries, radios. They're already getting information coming to them. So this is really a way to help parse that information and, provide it to them in a way that they can, process it. If you get too much information at one time, it's almost as bad as not getting any information.
Yeah, yeah, I can imagine, overly distracting things going at once when you're trying, to focus on the danger, the reality of what's in front of you. That can be probably a real hazard to have too much going on. So, tell me, you said the military's been pushing for this for a while. Is that what's really driving, the demand for, improving the technology in these applications?
It's certainly provided some funding for it along the way in certain circles. There's definitely, a lot of small companies that kind of leverage those relationships with military to be able to fund programs, and, that level of, It used to be 50 or 75,000, and some of them are up to as much as $1 million now, kind of, packages for, simple research programs, that kind of stuff. A lot of them are just asks out looking for specific solutions to problems and seeing what people come back with in terms to fill those solutions. And so that's a piece of what we've been doing. And their goal generally is to push these things through until they become productized by the companies, become something that becomes out there, available to the public. The majority of our technology we've been adapting things that we've already been building for consumer markets. Our primary market, has mostly been for industrial space, a lot of industrial, and I'd say, medical, that kind of thing as well. But a lot of it has been, warehousing solutions and that kind of thing, ways to, you know, alternative barcode scanners and organizing it and stuff. And it's stuff that kind of flows. Very boring details in the middle of things that cause everything else to move and to continue to work. I mean, it's important, boring details, unfortunately.
Sure. And yeah, and accuracy and whenever you're, doing something like this is always important, but there's a big difference, I guess, in what an inaccuracy could mean and, a barcode scanner or something a frontline soldier is wearing. So is there a different approach when you handle something of this, magnitude that kind of is taken on like the front lines, or that could be, something that provides a, soldier information while they're out in the thick of it?
Well, and a lot of that is, the robustness of the information and everything else that's there. I mean, so that's getting into the software and supply chain information. That would be, you might have like, 3 Harris radio or something that's tied through, but those all have video components and that kind of stuff now. So you want to make sure that, think of them because they're local, by the way, in town here. But the, information that comes from the systems that are being worn by the soldiers on their packs and everything else already that's coming through, all that is already secured. So it's really looking at a secured local link to that to get it to the eye. For us, it's much more about just delivering that, information where they might not be able to hear, or they might not be able to, interact in some other way that, visual cues are, a very good way to get information to somebody. And then it's a question of sorting out and what that is. One of the things we didn't get into too much was, what happens when you start pushing that field of view way out, make the image really big, and you're competing with daylight or those kind of things. So you've got, there are a wealth of other challenges that I didn't quite get into when I was talking about the parallelism, actually just making the waveguides, the projector side. The brightness, being able to provide that field of view to a level with the environment around them and that kind of thing.
Now, are there, bottlenecks in this technology? Because there's always, a push for more, quicker, smaller, all those things. Are there bottlenecks in this technology, be it waveguides or just other optical systems that we're still trying to like overcome to really advance optics and AR in these applications?
Yeah, so there's a leapfrogging relationship between the projectors and the field of view available and the waveguides themselves and the brightness. Is kind of what I was starting to kind of jump ahead,
Yep.
which is that the projectors, fundamentally, if you have a projector that gives off a certain number of lumens, a certain amount of photonic energy, and that if you take a 30-degree projector, and then I'm going to expand it to 40 degrees. So I'm going to, feels like 25% more. The image that comes out is going to be fundamentally about half as bright. You go to 50, 51 degrees or something like that, it's another halving again. So by the time you get up to 67-degree field of view, you're thinking like, oh, I want this big, cover my whole field of view kind of a thing, which is 90, 100 degrees out. You're cutting that light in half and half and half and half. And if you do that enough times, it's really hard to get enough brightness out of the system. You start dealing with a lot more complexity. Oh, I need multiple stacks of waveguides. I need multiple projectors. I need all these different things to do. One of the things that's been happening is, that kind of 30, 40, 50-degree field of view range, which is like a big screen TV in front of you, kind of a range, is a very useful set of parameters to work towards, both on the projector side and the waveguide side. So there's the, materials. There's a lot more focus in the industry on different materials, making things available. High index glasses, high index polymers, things that we can use to make our waveguides out of. And then the projector technology is improving. We're moving from LCDs and LCOSs to DLPs have been around for a while now. Digital light modulators, they're micro mirror arrays, and then the newest things are micro display, micro LEDs themselves.
Mm-hmm.
Micro LEDs are single pixel emitters, so it's an array of pixels that all of them emit light, and they can get to the brightness that we need for the waveguide systems to work. Waveguides, to a certain extent, as the field of view gets larger, they throw light all over the place, and they're really friendly and nice to get your head into, but they need to have really bright sources to work. It's really what it comes down to. So the relationship between the projector and the waveguide, getting the projector that's bright enough to support the field of view that we can get out of the waveguide is fundamental to what we do.
And talking now with this technology and not just to bring the display to the eye, but what it's carrying, and we know AI is kind of working its way into seemingly everything. So how can these waveguides, these AR headsets, how can this all kind of bring AI to the front lines in a useful fashion? And are there any what are the risks and advantages that can come with that?
Yeah, so the AI glasses, particularly in the consumer space, we're seeing a lot more integration of that. The military side, I haven't seen the ways in which they're integrating that part of the system because we're not privy necessarily to that part of the system in it. The AI on the consumer side, I would say that the marriage of, once you can hold up a camera because you mount a camera in most of these systems and you're interacting with the world in a real sense, the AI's ability to provide visual information back to you or to highlight sections of the video, or, hey, cut this wire over here and actually be able to highlight it in your field of view is a very powerful thing to be able to do. We're visual creatures, so visual information coming back from the AI is, huge. The other thing too is that you end up often in environments where you can't, just recently Paul was up on stage, Paul's our CEO, giving a talk and wearing AR glasses, and somebody asked, hey, who's actually using their product now on stage? And everybody else on stage was wearing glasses that didn't have displays. And they all said, well, we had to turn them off because of the audio. And Paul was like, well, actually, I just got a message reminding me of a meeting I have with, the guy on the end of the stage. And it was because of the visual cues he was getting from it that were subtle enough that aren't going to interrupt what he's doing or be able to hear or interact with the world around them. So the power of the visual cue compared to simply an audio cue is powerful, and I'm sure that that's the kind of thing that they're working through. Every kind of assessment, every kind of processing is starting to be done through AI now, and that's just the way that's going to change. I think that the production of these is it's as much art as science a little bit today still. The technology, the computers, the processing to be able to model the results of how these things come together. One of the things we've been working on is expanding our teams in-house, chemists and modeling engineers to be able to, really, take some super high-end computers, running multi-day simulations, sometimes week-long simulations, trying to come up with, how these things behave and interact. So the future of this is going to be dependent upon, the research that's being done today, and that's what we're trying to stay at the forefront of in terms of, making advances in what we can build, and that's. So the modeling, the chemistry, the getting the indexing materials up. I didn't say it explicitly before, but I mentioned the index 2 or 3 times, but didn't say what it was. Is the higher the index of the material, the more light can get folded into the waveguide itself. So you end up with a scenario where a 1.6 index waveguide might be good for a 30-degree field of view, say. A 1.8, 1.9 might be good for a 50, 55. If you want to get into like a silicon carbide or one of those things with a 2.6 index, something up higher than diamond, you're going to end up with something that can support, a 67 degree field of view.
Well, Rob Schultz, thank you so much for giving me the time and sharing your insight. We really much appreciate it.
All right, thank you very much.
With that, we conclude another episode of All Things Photonics. Thank you to our sponsors, to the technical staff behind the scenes, and to continued support from the Photonics Media editorial team. As always, questions, comments, thoughts, and ideas are welcome. Let us know how we're doing via email at allthings@photonics.com. All Things Photonics is available on all major platforms and on our website, photonics.com.